For all of human history, we have looked up at the stars and wondered, what powers them? The answer is fusion, the most powerful energy source in the universe. Now, imagine if we could bottle that power. Imagine a machine that creates a miniature star, right here on Earth. A machine that generates nearly infinite clean energy, with zero carbon emissions and no dangerous long-term waste. This isn't science fiction. It's happening right now in the south of France. It's called ITER, the most complex machine ever built by human hands. To understand why ITER is so important, we have to understand the difference between fission and fusion. Current nuclear power plants split heavy atoms apart. That's fission. It works, but it creates dangerous radioactive waste. Fusion is the opposite. It creates energy by smashing light atoms together to form heavier ones, exactly like our sun does. The fuel? Hydrogen isotopes found in seawater. A bathtub of water and a laptop battery's worth of lithium could provide enough fusion energy for one person's entire lifetime. So, how do you build a star on Earth? You need a bottle that can hold something hotter than the sun. Enter the Tokamak. It's a magnetic cage shaped like a donut. Inside this chamber, hydrogen gas is superheated until it becomes plasma. But here's the catch. This plasma needs to reach 150 million degrees Celsius. That is 10 times hotter than the core of the sun. No material on Earth can touch it without melting instantly. To contain this hellish heat, ITER uses the world's most powerful magnets. These superconducting coils create an invisible magnetic field that keeps the plasma floating in midair, away from the walls. And here is the wildest engineering paradox. To create the hottest place in the solar system, the magnets right next to it must be cooled to minus 269 degrees Celsius, almost absolute zero. It is a machine of extremes, the hottest hot and the coldest cold, separated by just a few meters. Building this Leviathan is a logistical nightmare. ITER is a collaboration between 35 nations, including the US, China, Russia, and the EU, representing half the world's population. Millions of components, built in factories all over the world, have to fit together with millimeter precision. It's expensive. The cost has ballooned to over $25 billion, and it's years behind schedule. Critics ask, is it worth it? Is it too complex? Too late to save us from climate change? But if it works, it changes everything. ITER's goal is simple but revolutionary. Q equals 10. For every 50 megawatts of power used to heat the plasma, it aims to produce 500 megawatts of fusion power out. It will be the first machine in history to produce more fusion energy than it consumes on this scale. It won't put electricity on the grid yet. It's an experiment. But it is the final step before commercial fusion power becomes a reality. ITER is humanity's biggest gamble. It is the cathedral of the 21st century. It's slow, it's expensive, and it's incredibly hard. But the prize is a world powered by the same engine that lights up the stars. And that is worth fighting for. Do you think fusion will arrive in time to save the planet? Let me know in the comments. And if you enjoyed this deep dive into extreme engineering, hit subscribe. Thanks for watching.